Hey guys, I'm going to go over the on your own practice for 1.10, use algebra to describe geometry. So which choice describes the transformation? So you're going from xy to x plus 1y. So x is added 1 and y stays the same. X, that moves in the horizontal direction, okay? And if you add 1, that moves to the right. So it's translated, which is a slide, 1 unit to the right. All right. So the mapping rule, xy goes to x minus 4 and y remains the same. Once again, the translation is happening to x. That's the horizontal direction. And let's see what our drop-down choices are. So it is a translation when you slide. And minus 4 means you're moving 4 units to the left. All right, which answer choice shows this transformation? So once again, y is staying the same, so we got to check those. It can't be this one because y did not remain the same. It can only be this one or this one. We have to select all the correct answers. So x is minus 4. So negative 3 minus 4 would not be positive 1. Let me double check that on my calculator. Negative 3 minus 4 is negative 7. So that can't be it. All right, so now we have 1, and we're going to subtract 4, and that would give us negative 3, and y stays the same. So this one only has one answer. Oh, I missed one. I didn't scroll down. So 2 minus 4 would be negative 2, and the y stays the same here. My bad. Gotta scroll down. There we go. Let's try this again. Now, the mapping rule, xy goes to x and negative y. All right, so I have a little cheat sheet I'm going to pull up. So, the reflection over the x-axis, x stays the same and y becomes the opposite. So remember that negative doesn't mean necessarily always negative. It just means the opposite. So this is a reflection, and it was over the x-axis. There we go. So now we have to find some actual coordinates that follow this rule. So remember, x stays the same. Let's make sure we're all scrolled up. So x stays the same here, here. X does not stay the same here or here. So it can't be either one of those. So we just have to check the y now. The y does the opposite. So a positive 6 becomes a negative 6. And a positive 5 becomes a negative 5. So these first two. There we go. All right, now this one, something is happening to x and y. This is a translation. They're sliding. So x has a positive 4. Remember, that's the horizontal direction. So it is sliding 4 units to the right. And then the y is the vertical direction. And minus 2 means it goes 2 units down. Let's check out there we go. All right, so let's find some coordinates that follow this. So x and y are both changing, so we can't use that to help us. So x is plus 4. So 3 plus 4 is 7. So that one is good. And then y is minus 2. So negative 3 minus 2 would be negative 5. So this one works. All right. 5 plus 4 would be 9, not 1. So it can't be this one. 4 plus 4 would be 8, not 0. But negative 2 plus 4 would be positive 2, so it could be this one. And then negative 6 minus 2 would be negative 8. And that shows you the work. All right, now we're actually going to translate some polygons. So we're going to use the mapping rule to translate the figure on the coordinate plane. We have to subtract 4 from x and add 5 to y. So we have to take each point and do that. So I might have to remind myself. So x minus 4. So we're going to take this first point here. Don't click it. So the x coordinate is 4. So we're subtracting 4. So the new x coordinate would be 0. We would move to here. And then the y coordinate is plus 5. So if we add 5 to that, we go up 5. 1, 2, 3, 4, 5. All right. Now let's take our next coordinate. Our next coordinate, we subtract 4. Go to the left 4. 1, 2, 3, 4. And we are going to go up 5. 1, 2, 3, 4, 5. Let me just double check. To the left 4, up 5. Yeah. Last one. I'm going to go to the left 4, x first. 1, 2, 3, 4, and then up 5. 1, 2, 3, 4, 5. And you connect these by clicking the first dot again, and it makes a shape. And now we can check, and we got it right. All right. Now we're going to use the mapping 2 rule to reflect the triangle on the coordinate plane. And this one, x and y switch places, and we can look at our cheat sheet that we'll get. And when x and y switch places, that's a reflection over the line y equals x. So that's what this line is, y equals x. So it's going to reflect over that line. But really, we just need to know that these coordinates are going to switch. So this first one, the coordinate is negative 6, 6. And the new coordinate is going to be positive 6, negative 6. They're just going to switch places. So positive 6, negative 6. All right, and we'll look at this one here, which is negative 2, 1. So the new coordinate is going to be 1, negative 2. They just switch places. They don't change. This last one, the coordinate is negative 6, 2. So the new coordinate is going to be 2, negative 6. Click the last one, and now we can check our work. And we did what we needed to do. All right. This one we're going to use our little cheat sheet. So xy becomes switches places, and y does the opposite. So they switch places. So y comes first, but y also does the opposite. So that is a rotation counterclockwise of 90 degrees, gives you negative yx, but also a clockwise rotation of 270. So let's see what our options are. So we have counterclockwise of 90. So we're going to use that one. Now, they don't switch places. X just does the opposite. Y stays the same. Let's look at our sheet. X does the opposite and Y stays the same. That is a reflection over the Y-axis. Alright, and now they stay in the same order, just both X is opposite and Y is opposite. So that is a reflection across the origin. X is opposite and Y is opposite. Let's see if there's a rotation like that. Just checking. Also a rotation of 180 degrees. So let's see what our options are. Let's check our answers. And that's correct. Last one. Which mapping rule represents a 90-degree clockwise rotation about the origin? So let's look at our cheat sheet. Clockwise, 90-degree clockwise, 90-degree clockwise. X and Y switch places and X does the opposite. So it becomes Y negative X. And the more you practice, the more you'll learn these. And that's on your own practice, 1.10.